Hey y'all, welcome to another Leetcode video. This is sort colors. This question is actually asked by Amazon. So we're given an array nums with objects red, white, and blue, and to sort in place, so objects with the same color next to each other in the order of red, white, and blue, and the numbers 0, 1, and 2 are represented of the colors red, white, and blue respectively. And we can't use the sort function of a programming language of choice, and we have to sort it in place, which means we cannot use any extra additional memory, and we only have to manipulate the memory that we are given by the nums array itself. So to get started, we need to get rid of the redundant fact of red, white, and blue colors. All we're doing is just sorting an unsorted array in place. So as you can see, we're given an unsorted array, and then we sort it in place. So we have our zeros first, then ones, then twos, so we sort it ascendingly. And in this example, we do the same thing, just sorting it ascendingly in place. 0, 1, and 2 from 2, 0, 1. So there are many types of array sorting algorithms. So to name a few, there's selection sort, insertion sort, quick sort, bubble sort, radix sort, and the list just keeps going on. There's many different types of array sorting algorithms. But the purpose of this video, I'll be using a bubble sort. There's also quick sort in this case. The difference between these two is that obviously there are different functionalities in how they approach the problem algorithmically, but time complexity wise, quick sort is O of n log n versus bubble sort is O n squared. And obviously n log n is a lot better of a solution than O(n) squared. So yeah, but in order for this video, bubble sort, in my opinion, is a lot more simple to implement. So for the purpose of the video, I'll go with kind of a simple solution for bubble sort. But yes, you are free to use quick sort as well, as it is faster and better, even for the interview process, etc. So yeah. So how bubble sort works is if I have kind of two pointers to my current index and the current index plus 1. So what I do is I look at my current index and be like, hey, if my current index is greater than the next index, then what I want to do is swap the values. If not, then I just continue traversing along my array. So is 12 greater than 9? Then yes, it is. Then I swap my values. So I put 9 here and then 12 here. Now is 12 greater than 11? Yes, it is. So now I swap my values again. 11 goes here and 12 goes here. Is 12 greater than 3? Yes, it is. So I swap 12 and 3. And then I start back to the start of my array and do it again. Is 7 greater than 9? No. Is 9 greater than 11? No. Is 11 greater than 3? Yes, it is. So I swap these values. And as you can see, you might understand the name of how bubble sort came along, because we're kind of bubbling the values up or down the array depending on if it needs to go up or down the array. Yeah. Is 11 greater than 12? No, it's not. So I start back at the start of my array. 7 greater than 9? No. Is 9 greater than 3? Yes, it is. Swap these values. And you probably get the idea of how this works. So 9 is greater than no. And then I start back here. 7 greater than 3? Yes, it is. 7 greater than 9? No. And at this point, we've kind of just sorted the entire array, just finishing off this loop. And then we're done. And then we exit. So yeah, this is the visual example of how bubble sort works. So now, the code implementation of the solution. So we're going to be running two loops, one for the current index and then the other for the current index plus 1. So for I in the range of the length of nums, and then we're going to have a j in the length of nums minus 1. And notice we have this minus 1 because we don't want an array index out of bounds error. So because if I have j keep going, because what we're going to be doing is we're going to be referencing the current index and then the current index plus 1. So if I'm at the end of my array, let's say if I'm at I right here and I try to do I plus 1, obviously there's no I plus 1 and it's out of bounds, so it'll just result in an error. Therefore, we do the minus 1, so it stops at 11, and then it can reference this last index plus 1 right here. And then what I do is if the current index that we're on at j, if it's greater than that next index, we're going to be swapping the values, as we saw earlier, the whole point of the bubble sort algorithm. So we just reassign the values. So we say nums of j plus 1 is equal to j plus 1 and nums of j. If you are unfamiliar with this syntax in Python, well, I think it's in many languages. You can assign multiple variables on one line. So now this nums of j becomes nums of j plus 1, and then our nums of j plus 1 becomes nums of j. So we're just swapping the values of the indices. And that's it. It's a super simple solution. Like I said, this time complexity is O of n squared, so it's not the fastest, but it's very simple to implement.